Hello everyone, we are the Mother Hovers, and for our presentation we researched robo-roaches. So to begin our plunge into the rapidly developing world of robo-roach technology, we will give you some of the applications, followed by an explanation of how this all works, paired with a rather entertaining video. Then we will introduce you to the brawn of the operation, the cockroach. Also, to wrap it all up, we will talk about where this technology is taking us and give a quick recap.
So you may be wondering why use electrodes to control a cockroach. In this case, there are many reasons to do so. The first is to make use of and study the mobility of the roach. The hexapod structure of the roach allows it to crawl through rocky terrain and obstacles that normal wheeled vehicles cannot navigate. Research could lead to farther development of six-legged all-terrain vehicles that can navigate parts of the Earth's terrain previously uncharted. Remote-controlled roaches also allow humans to better observe behaviors like mating and feeding more easily. Observing the behaviors of these cockroaches provides data that will eventually help us to keep them out of our houses. The roaches could also prove key to disaster relief. Because of their size and mobility, they will be able to pinpoint survivors of a natural disaster faster than human relief could, allowing for a more effective rescue operation.
Now that we've learned a little bit about why robotic cockroaches are being made, I'd like to tell you how they're being made. The diagram shown here on the slide was provided on the website of backyardbrains.com. It represents a circuit board they designed to be placed on the cockroach's back. This board is connected to 3 tiny wires. 2 are placed into the cockroach's antenna, and the last is placed into the thorax. Voltages are sent through either the left or the right antenna, causing the cockroach to respond by turning in the opposite direction. Controlled by remote, these voltages are used to steer the cockroach. Now we have a small video to show you Backyard Brains design in more detail. We hope you enjoy it.
To interface with the cockroach nervous system, we use very fine silver wire from AM Systems. Now grab your favorite soldering iron. We're going to sand a little bit of this wax off of his pronotum. The superglue we enjoy, carefully splay one of his wings and secure it with silly putty. You want to lightly poke the exoskeleton of his thorax. Park it in the small hole you just made in the thorax. Cut the antenna down to with only 1/8 to 1/4 inch left. The antenna are hollow, fluid-filled structures with a nerve running down the center. Park it just into the antenna. And now put the cockroach back in the ice anesthesia. Look how nicely organized it is now. Notice that nice wing flapping behavior when I pick him up by the connector. Now place the cockroach on the floor, and when he starts running, start stimulating the left and right sides and see what you observe. Good luck on your surgeries.
Now I'm going to tell you about the cockroach itself. The most commonly used cockroach for this experiment is the Madagascar hissing cockroach. Unlike many cockroaches, the Madagascar hissing cockroach is wingless, which makes it easier to control because it can't fly. Their legs are coated with psyllium, which makes them excellent climbers. They have a long life capacity of 5 years, which is useful in minimizing the amount of cockroaches that need to be used. The important areas of the cockroach's body that are used when controlling it are the cercis and the antennae. When the electric pulse is sent to the cercis through the circuit, it causes the cockroach to experience a fight or flight reaction and causes it to run forward. When an electric pulse is sent to either the left or right antennae, the cockroach will turn to the opposite side due to the same effect as shocking the cerci. Because of these specific attributes, cockroaches seem to be one of the best suited insects for this kind of procedure.
So, what are the future uses of these robotic cockroaches? Well, one, for example, is it can be used as an ultimate spy bot. For example, we could put cameras or recording devices on top of these cockroaches and navigate them into areas where humans could not reach, or we could navigate them into areas where Americans could not be, and we can spy on people. Micro air vehicles are cockroaches that we have been able to manipulate, and we can control their flight paths. Another example is mind control. If we can learn how to control these cockroaches, then possibly we could learn how to control humans. The third example for future use is OCD in Parkinson's patients. We can send electrical impulses into the basal ganglia of a human to prevent Parkinson's patients from being as anxious and obsessive compulsive as they naturally are.
In closing, I hope you all have gained a better sense of the importance and applications of this technology, learned a bit about how this all works, grown a deeper appreciation for the Madagascar hissing cockroach, and begun to visualize the possibilities for this type of technology. Thank you for your attention.